Everyone, in this video we'll be returning to Amazon Bedrock to explore one of the latest models that's taken this whole GenAI space by storm, and that's DeepSeek R-1 from the DeepSeek model family. And this model is especially known for its advanced reasoning capabilities across math, science-based problems, or just advanced reasoning problems, whether it's in code or other fields as well. And it's a very interesting paper. We won't dive into the data science nitty-gritty, but all of this is OSS, and you can go to the Hugging Face kind of repo here just to explore more of how they actually conducted training here. There's a heavy emphasis on reinforcement learning and some really nice new nuances that were introduced. So if you're interested more on the data science side of things, I'd explore that. I'll link this down below in the description as always. But what we'll do here is, right, we'll just try to understand how through Bedrock we can work with this model. And in coming videos, we'll obviously build more hands-on projects integrated with different features such as agents, RAG, kind of see where we can really use these different capabilities of it in a real world setting. But to get started, at least for this video, make sure that you can modify your model access and request access for DeepSeek R1. Right now, I'm in US West 2, but check the supported regions as well in the start blog, which I'll link below. But you can essentially enable access here just like we did for Claude in our previous kind of video series for Bedrock. So once you set that up, what we've done here is I've gone to SageMaker as always, just for my notebook environment. And here you'll see in classic notebook instances, I've spun up a notebook just for my different Bedrock samples that I'm working with. You can also work with this locally, wherever you have the credentials to really work with Bedrock, you can do that. But if you ever have any other tertiary operations or kind of stuff that you need to store that you don't want to locally, you can hop on one of these SageMaker notebook instances and provision extra storage. But with that being said, I have my Jupyter Lab environment right here, and I've cloned my repo, this Bedrock samples repo, and I'll share this down below with all the other links as always. And in here, I have a kind of introductory notebook for DeepSeek. And what we'll do is as different model families and providers are onboarded onto Bedrock, we'll make these kind of introductory videos just to showcase how you can quickly get started with the API there. And it can serve as kind of a template for you for whatever other GenAI projects or ideas that you might have. Now, if I come in here, right, into this notebook, it's going to be many of the same tools as we used in our Bedrock intro notebook. I'll briefly talk about them again. But what we'll do here is we'll import Boto 3, which is the AWS Python SDK to work with any service, as we've seen in some of my previous videos. If any of you watch, you'll see that you can work with SageMaker, S3, any AWS service through it. Optionally, if you have another language you're dependent on, you can use the requisite AWS SDK there. But here I import Boto 3. I instantiate my runtime client. This Bedrock runtime client essentially allows for me to invoke whichever model that I'm working with. I specify the region that I'm in, and then I specify the model ID specifically. And you can get all of these in the Bedrock console itself. So if I go here to Amazon Bedrock, and you'll see the different models that are provided here. Just take a second to load. You'll see the different providers here. You can go to the model that you might be working with, whichever one it is. So this, if it's DeepSeek, you can click on it, and once this loads right here, you'll see for the specific model you might be working with, which is R1 in this case, you'll see there's a bit of a model card kind of explaining further in terms of the specifics of the model itself. And then you'll see that model ID, which is essentially telling Boto 3, hey, this is the model that I want to work with. Any limitations in terms of the modality, kind of the token, max tokens that you could pass in, different language support, and most importantly, there's the API request shape. Keep in mind that these different model providers for these different models might expect the shape to be in different ways in terms of the way the prompt is structured. So you can take this API request to get a better understanding of what exactly you're working with. So here, for my text payload, this is the way DeepSeek expects it here. I have my delimiters surrounding my actual payload here. You could obviously use some kind of prompt templating or prompt engineering to kind of make this a variable instead that you could pass in, but I do that. I set a few other parameters at the LLM level itself in terms of what I want to work with. You can adjust these for your experiments. And then I serialize this payload, and then it's a simple invoke model API call where I essentially pass this body payload right there. I pass in my model ID saying I'm working with DeepSeek, and then I can generate a response. So for who is Roger Federer, you'll see that you have a response out here. And like I said, you can adjust the tokens generated to kind of play with it depending on your use case. Now, something new I wanted to introduce that we didn't talk about in the introductory Bedrock video is the Converse API, and I've also linked the documentation for it. But the Converse API, right, kind of adhering to the statement I was making before, these different model providers have different ways you need to structure the prompts. And this sometimes can make it a little difficult when you want to test the same, for example, payload across multiple different models. So let's say I want to see how Llama responds, how DeepSeek responds, how Claude responds, etc. Kind of like different models where you just want to test these payloads across. You don't want to restructure the prompt every time for these. So what the Converse API does is it makes it a little simple in that sense. It provides a unified kind of um, structure for your payload itself. And you can see it in this conversation variable where you have your user role, and then you can pass in a list of the different kind of user messages or input prompts that you might have. And this stays universal across all different models, right? So whether I'm invoking Llama, whether I'm invoking Claude or anything else, this Converse API call right here, I can keep this payload structure the same. So if we see it's the same runtime client that I'm working with, the API method itself is different, and I pass in the same model ID. I pass in this new structure, and I can adjust this depending on whichever model that I'm working with. And even simpler, right? They add an inference config dictionary right here, where you can pass in the different parameters. So whereas in the invoke model API call, I kind of had to include that as part of the payload itself. That's been decoupled a little, where you can have this as its own object, where you can pass in the different values here. And if you see here, I parse the response text similar to how I did before. Same thing that's happening there. And the last thing I wanted to cover briefly, this is a bit of a shorter video just to get you started with DeepSeek, is we can iterate over some sample data sets, right, from Hugging Face. So if you ever want to evaluate or test a model for its specific capabilities, we know R-1 is especially good with math and advanced reasoning problems. What I did here was I installed Hugging Face data sets, which is a bunch of different data sets that you can work with. Obviously, check the license in terms of your requirements there. But you can essentially go to this data sets tab here. You'll see that there's different data sets that are tailored for your use case. So if I had a summarization use case, for example, I can check in this data sets tab here and Hugging Face, pull that down, run my model inference or training through it. So this in general is just another concept that we're introducing or construct that we're introducing. This is a great place to get started if you're trying to find a OSS data set in terms of fine tuning or just running inference or evaluation. In this case, what I do is I pull this data set down, which is a bunch of math problems. And you might have to rerun this cell here just if it times out. But essentially, I pull down this data set and I can look at some of the sample kind of input payload questions right here. So these are different math-based reasoning problems, not like simple 3 plus 4 or like any kind of PEMDAS type problems, but actual reasoning-based problems where the model's going to have to think a little, which is really what R-1 kind of specializes in, right? And what I do here is I then take these different problems. I'm only going to iterate over 10 of them. I made a little method, which is just using our invoke model API call just to make it a little cleaner. And I just iterated over 10 of those sample questions. And then for each one, you can see DeepSeek kind of showcasing its reasoning capabilities as it answers it. You see it break down the problem into smaller parts. And then as it breaks it down, you see the reasoning capabilities that we were adhering to earlier. And then through all these 10, you can kind of just experiment, play with it, adjust it, try it with different problems of your own if you're interested. But here's just a sample use case of how you could do it. And the intuitive next step for something like this, we won't do it in this video because it's a bit too meaty by itself, is evaluating this LLM's performance, right? So there's different ways to evaluate different LLMs across different tasks. So even for reasoning-based tasks or even for summarization or Q&A-based tasks, there's different ways that you can evaluate an LLM. So something that you might want to explore, kind of a sneak peek for what's on in this series, is how can I evaluate my LLM depending on the task that it's working on and what is the exact architecture behind it. But yeah, at a high level, that was mainly what I had for today in terms of just introducing that DeepSeek support on Bedrock itself. I think it's a great model to add to this list here, and it just gives you another option in terms of your LLM use cases that you might have. So take it for a spin, play with it for some sample projects. Like I said, in the coming videos, we'll also explore other kind of actual Gen AI use cases or production Gen AI use cases using different features such as agents, knowledge bases, guardrails, and more. So we'll build upon just this simple API call to really showcase how an end-to-end Gen AI application might look like. So stay tuned, and thank you as always for watching. Feel free to leave any feedback, and if you enjoyed the video, give a like and subscribe. Thank you as always, and I'll see you all very, very soon.